Matter. To live, each living being breathes in air. Life on this planet has been possible due to the presence of oxygen in air and water on Earth. To keep going, we need energy, which is supplied to our body by the food we eat. To live constantly, we are using substances in different physical states around us. Can we give them a name collectively? You may be surprised, but the answer is yes. They are all different forms of matter. What is matter? Matter is defined as anything that has mass and occupies space. Everything around us is made up of matter. It is made up of atoms. Classification of matter. In nature, matter exists in three forms: solid, liquid, and gas. All three forms of matter is made up of very small particles which exist independently. These particles are called molecules. Intermolecular force and intermolecular space. As a child, you must have played with building blocks and made different shapes by changing their arrangement. In a similar manner, molecules are the building blocks of matter, and different states of matter are due to difference in arrangement of molecules. Molecules attract each other. The force of attraction between molecules is called intermolecular force of attraction. In a similar manner, the space between any two molecules is called intermolecular space. Solids. Molecules are closely packed in a solid with little or no intermolecular space but very high intermolecular force of attraction. The molecules cannot move but vibrate at their places. Molecules possess less energy in a solid. Properties and reasons for exhibiting the properties. 1. Solids have a definite shape and occupy a definite space. That is, solids have a fixed volume. Reason? Since molecules are closely packed in a solid, they have least intermolecular space and strong intermolecular force of attraction. They cannot move from their place, giving solids a definite shape and volume. 2. Solids cannot flow. Reason? Due to the strong intermolecular forces, they cannot flow. 3. Solids are incompressible. Reason? As there is no place left in between the molecules, therefore, molecules cannot move closer to each other. As a result, solids are incompressible. 4. Solids have any number of free surfaces depending on their shape. Reason? Solids are those substances which have a definite shape and volume. They are non-compressible, cannot flow, and therefore have any number of free surfaces. Liquids. In case of liquids, the molecules are not tightly packed and their position is not fixed. As compared to molecules in solid state, these molecules possess more energy. In comparison to solids, there is greater intermolecular space and lesser intermolecular force of attraction. The attraction between molecules is less, but still not so less that they may move in any direction. They can easily slide over each other and exchange or even change their places. Properties and reasons for exhibiting the properties. 1. Liquids don't have a definite shape but take the shape of container in which they are kept. Reason? As molecules of liquids are not tightly packed, they can easily shift and adjust by taking the shape of container in which they are kept. Not being compact, liquids don't have a fixed shape. 2. Liquids have a fixed volume. When we say half cup of milk, we have an idea as to how much space will be occupied by it. Similarly, if you are thirsty, you know how much water you can consume because we have a general idea of the volume of liquids. Reason? Since intermolecular force of attraction in a liquid is not very less as in the case of solids, hence the molecules remain at an approximate distance from each other. Like solids, their places are not fixed, but they just can roam away from their places. 3. Liquids flow from a higher level to a lower level under normal conditions. You can attribute this property to intermolecular force of attraction in liquids which don't allow molecules to stray. 4. Liquids can be compressed slightly because they have a definite volume. 5. Liquids, unlike solids, have only one free surface. Reason? Since liquids have to be stored in a container, they take the shape of container. On 3 sides, they are bound by the walls of container, but on the 4th side, they face the mouth of container and this is their free space. Fact: this is a 4th state of matter called plasma, but it is not often seen. It only exists at very high temperatures on inside the sun and other stars, or on Earth at low pressures. It consists of atoms split up by great heat or electricity. Thus, any material which has a definite volume but no definite shape and has one free surface is called liquid. Activity: take a small cup filled with water and a glass bowl and a coffee flask. Note the shape of water in the cup. It has one free flat surface as shown in the figure. Now, invert the cup in a glass bowl. You will find that water flows into the bowl and takes the shape of the bowl, but its top surface is free and flat. Pour the water from the bowl to the coffee flask. You will find that water flows into the flask and takes the shape of the flask with its top surface free and flat. Now, again, pour water from coffee flask to the cup. What do you observe? The cup again gets filled and the water takes the shape of the cup. Gases. In this state of matter, molecules are far apart from each other. There is maximum intermolecular space and minimum intermolecular force of attraction. Molecules possess high energy and move freely in all directions. Properties and reasons for exhibiting the properties. 1. Gases have no definite shape. They take the shape of containing vessel. Then, what is the difference between gases and liquids? Gases occupy every bit of space available. So, while you can say, "Give me a cup of tea," but you cannot say, "Give me a cup of air." Reason? As there is negligible or very less attraction between gaseous molecules, they move anywhere. 2. Air occupies space. Activity: take an empty glass tumbler and lower it vertically downward in a trough of water. Do you find it easy to push it down? What do you observe when you tilt the glass? In the first case, it is not easy to push down the glass. When you tilt the glass, bubbles of air escape out and water enters the glass. First of all, why was it difficult to push the glass? An empty glass is not empty, but is full of air. When you push an inverted glass in a trough of water, air resists the entry of water as it has occupied all available space in the glass. When you tilted the glass, air escaped as bubbles and water entered the glass. This activity proves that air occupies space, that is, it has volume, but its volume is not fixed as it fills up the entire container. 3. Gases have no definite volume. Reason: gases have large intermolecular space between them, with molecules free to move in any direction. Gases can flow in all directions because of negligible intermolecular force of attraction between their molecules. Activity: take an empty glass bottle and pour a few drops of perfume in it. Smell the bottle. You will be able to smell the perfume. Now, place this bottle in your drawing room and leave it undisturbed for a few minutes. You will observe that the whole room is filled with the smell of perfume. From this investigation, we conclude that gases have no definite volume. They have a property to fill the entire space available to them. 4. Gases are highly compressible. Reason: owing to large intermolecular spaces between them, gases can easily be compressed. What does a mechanic do when he fills air in your cycle tube? He allows compressed air to enter the cycle tube and fill it. 5. Gases have no free surface. Reason: if you keep gas in a container, then to avoid escaping of gas, you must seal the container. Example: LPG cylinder at home is sealed as it contains cooking gas. Hence, gases have no free surface. Comparative study of the properties of solids, liquids, and gases. Property: solid, liquid, gas. 1. Shape: fixed, no fixed shape, no fixed shape. 2. Arrangement: packed, very tightly packed, loosely packed, very loosely. 3. Force of attraction: very strong, strong, negligible. 4. Intermolecular space: negligible, medium, maximum. 5. Volume: definite, definite, not definite. 6. Compressibility: non-compressible, can be compressed slightly, can be compressed easily. Do you know, substances like iodine, ammonium chloride, and naphthalene are common sublime substances. They change directly from solid to gas. Sublimation: some substances change directly from solid to gas on heating. Such a conversion is called sublimation. When cooled, the vapors of such substances directly solidify. The solid thus obtained is called a sublimate. Iodine, ammonium chloride, and naphthalene are common substances that sublime. A direct change of state from a gas to a solid is called deposition. Heating a solid to change directly to gaseous state without the intermediate liquid state. Example: heating of ammonium chloride. Ammonium chloride, solid. Cooling, ammonium chloride, vapor. Do you know, substances like iodine, ammonium chloride, and naphthalene are common sublime substances. They change directly from solid to gas. Change of states: matter can be changed from one state to another. A substance can exist in any of the physical states. We can change the physical state by changing the temperature or pressure. For example, water can be changed from liquid to solid ice at 0 degrees Celsius and from liquid to gaseous state at 100 degrees Celsius. The process can also be reversed. If we cool steam, we get water, which on further cooling changes to ice. Based on above observations, we can conclude that water can exist in all the three states, and a change in state can be brought about by changing the temperature or pressure. Other substances also behave similarly at different temperatures and pressures. Even gold, silver, iron, and copper can occur in all three states, but not under normal conditions. Melting, conversion of solid into liquid on heating, is called melting. Example, conversion of ice, solid, to water, liquid, on heating. Vaporization, conversion of liquid to vapor, is called vaporization. It occurs at all temperatures. Example, conversion of water, liquid, into water vapor. Condensation, conversion of vapor into liquid on cooling is called condensation. Example, conversion of water vapor to liquid water on cooling. Freezing, conversion of liquid into solid on cooling is called freezing. Example, formation of ice, solid, on cooling water, liquid. Do you know? The word atom is derived from the Greek word atomos, means that which cannot be divided. What is matter made up of? After getting a general idea about matter and the various states in which it exists, let us learn about nature of substances. For example, water and mercury exist in liquid state, but their chemical composition is different. Mercury is an element and water is a compound. Let us take another example. Mercury as well as oxygen are elements, but they are so different from each other that while mercury is toxic or poisonous in nature, oxygen is life-giving. First of all, let us know what is an element and what is it made up of. Elements. An element is a pure substance which cannot be broken down into two or more pure substances by chemical means. There are 118 elements confirmed by the IUPAC on December 30th, 2015, known to man, which have been placed systematically in a table called periodic table. Elements are further divided into metals, non-metals, and noble gases. We have learned previously that various states of matter exist due to different arrangements of molecules in them. Now, we will learn that molecules are not the smallest particle of matter, but it is an atom, which is the smallest particle of matter. An atom is the smallest particle of an element which may or may not have independent existence, but always takes part in a chemical reaction. All elements are made up of atoms. Atoms of an element are similar to each other, while atoms of different elements differ from each other. Classification of elements. What are metals, non-metals, and noble gases? All elements do not resemble with each other and can be categorized into 1. Metals, 2. Non-metals, 3. Metalloids, 4. Noble gases. Metals. Metals are those substances which have the following characteristics. 1. They have luster, which means that their surface shines when light falls on it. Example, gold, silver, copper, etc. 2. They are good conductors of heat. Example, all cooking vessels are made up of metals. 3. They are good conductors of electricity. Example, household electrical wiring is made up of metal. 4. They are ductile and malleable. It means that they can be drawn into wires and beaten into sheets respectively. Example, copper is used for making wires, while foil of aluminium is used to pack food items. 5. They have high melting point and boiling point. Cooking vessels are made up of metals or their alloys because they can withstand high temperature and do not melt. Their melting point is high. Similarly, mercury, which is a metal but exists as a liquid, is used in measuring body temperature in thermometers as its boiling point is very high. They are sonorous. It means that they produce a ringing sound when struck. Do you know? Mercury is the only liquid metal. Non-metals. An element can be called a non-metal if 1. It has no luster and cannot be polished. Example, coal. 2. It is a bad conductor of heat and electricity. 3. It has a low melting point and boiling point. 4. It is neither malleable nor ductile. 5. It is generally a gas or soft solid at room temperature. Bromine is the only non-metal which exists as liquid at room temperature. Examples of non-metals existing as gas are oxygen, nitrogen, etc. and soft solid is phosphorus. 6. It is not sonorous. It does not produce a ringing sound when struck. Do you know? Non-metals are bad conductor of electricity except geoplute, form of carbon. Metalloids. Metalloids are elements that have properties of metals as well as non-metals. Arsenic, germanium, silicon, and antimony are some examples of metalloids. Noble gases. Both metals and non-metals are reactive. They react with acids or displace less active metals or non-metals from their salt solutions. However, there are 6 elements in periodic table which are totally unreactive. They are helium, neon, argon, krypton, xenon, and radon. Radon is the only noble gas that occurs in Earth's crust. Compounds. Elements combine differently to form compounds. The combination of elements occurs in a fixed ratio. Thus, a compound can be defined as a molecule which contains 2 or more elements chemically combined together in a fixed ratio. For example, water is a compound formed by 2 elements, that is, hydrogen and oxygen in a fixed ratio of 2:1. Do you know? A compound, a substance that is formed when 2 or more elements combined chemically in a fixed proportion. Formation of a compound. Let us take some iron filings and sulfur in 1:1 ratio and spread them over a paper. Now, bring a magnet near this and see that iron filings start sticking to the magnet. Sulfur is seen as a yellow substance. Transfer the mixture in a test tube and heat for a long time. You will notice that even after you stop heating the mixture, the test tube continues to glow for some time. Cool the test tube and remove its contents. The test tube contains a metallic solid which can be powdered. Spread this powder on a paper and pass magnet over it. Nothing sticks to the magnet. When iron was heated with sulfur, their atoms combined to form molecules of iron sulfide. If we break the molecule of iron sulfide, we will not get atoms of similar type as in the case of iron or sulfur molecules. They will differ from each other as they are of different elements, but molecules of FeS will resemble each other. Diagrammatically, the change can be shown as follows. If you look at the table showing symbols of elements, you will find the symbol of iron is Fe and sulfur is S. Hence, the formula of iron sulfide is FeS. Symbols. Language of chemistry is based on symbols. A symbol represents an element. It also represents an atom of an element. A chemical symbol is the representation of an atom of an element. Hydrogen, H, oxygen, O, nitrogen, N, carbon, C. Rules of writing symbols. Symbols of some elements are derived from the first letter of their English names, and they are represented by capital letter. Do you know? A new system of symbols proposed by the scientist Berzelius. Table showing symbols derived from the first letter of their English name. Elements, symbols. Hydrogen, H, carbon, C, oxygen, O, phosphorus, P, sulfur, S, iodine, I. If two or more elements have names beginning with the same letter, then one more letter is added to the first letter, and second letter will be small. Table showing symbols derived from two letters of their English name. Elements, symbols. Helium, He, magnesium, Mg, manganese, Mn, aluminium, Al, silicon, Si, chlorine, Cl, chromium, Cr, calcium, Ca, cobalt, Co, zinc, Zn. Symbols of some elements are derived from their Latin names. Table showing symbols derived from their Latin name. Elements, English, Latin. Symbols. Sodium, natrium, Na. Potassium, kalium, K. Iron, ferrum, Fe. Copper, cuprum, Cu. Silver, argentum, Ag. Gold, aurum, Au. Mercury, hydrargyrum, Hg. Lead, plumbum, Pb. Chemical symbol represents the number of an atom in one molecule of the element. Do you know? The number of atoms present in one molecule of a substance is known as its atomicity. Table showing few elements with their atomicity and formulae. Elements, chemical, atomicity. Helium, He, 1, monoatomic. Sodium, Na, 1, monoatomic. Potassium, K, 1, monoatomic. Calcium, Ca, 1, monoatomic. Hydrogen, H2, 2, diatomic. Nitrogen, N2, 2, diatomic. Chlorine, Cl2, 2, diatomic. Ozone, O3, 3, triatomic. How are molecules of elements different from that of compounds? An element is made of only one kind of atoms, therefore its molecule contains atoms of one kind only, but a compound is made of different elements. Molecules of a compound contain atoms which are dissimilar. For example, a molecule of oxygen contains 2 atoms of oxygen, but a molecule of sulfur dioxide is made up of 3 atoms, 1 of sulfur and 2 of oxygen. Chemical formula. The chemical formula represents the number of atoms of the elements present in one molecule of the compound. Do you know? Chemical formula of water is H2O. It represents a molecule of water formed by the combination of 2 atoms of hydrogen and 1 atom of oxygen. Valency. The combining capacity of an atom of an element is called valency. The number of atoms present in a molecule of a compound depends on the combining capacity of the elements forming the compound. Do you know? Some elements have variable valency also. Table showing valencies of some common elements. Elements, valency. Hydrogen, 1. Sodium, 1. Potassium, 1. Oxygen, 2. Magnesium, 2. Zinc, 2. Aluminium, 3. How to write chemical formula? We can form chemical formula easily by following steps given below. Step 1. Write down the symbols of the elements that make up the compound. Example, X and Y make XY. Step 2. Write down the valency of each of the elements X1, Y2 if valencies are X is equal to 1, Y is equal to 2. Step 3. Interchange the valencies and write them as subscripts next to the symbols. We do not write any subscript if the valency is 1. Example, X1, Y2 is equal to X2, Y1 is equal to X2, Y. Step 4. Simplify the formula by dividing the valencies by a common number. If not divisible by any common number, then do not divide. Like X2Y will be same.